All right, friends, so we have written equations in slope-intercept form already, but we're going to learn about a really useful equation as well. This equation is called point-slope form. Now, mathematicians like to name things very accurately, so the reason that it's called a point-slope form is because the things you plug in are parts of a coordinate point and a slope. So this equation, y minus y1 equal to m times x minus x1, all you have to fill in is the three highlighted letters here. The y1 is going to be the y-coordinate, so the second number from any point on that graph. So the y-coordinate, or the second coordinate in an ordered pair, of a point that is on that line. Looking at the blue part at the back, the x1 is going to be the x-coordinate, so the first number in an ordered pair that is a point on that line. Because we're looking for a coordinate point on that line, we're going to split it into the first part, the x, and the second part, the y. Now this letter hasn't changed. The m is still your slope, which is your rise over your run. We will also use the slope formula. So if you guys want to write that down, it is something you will need. The slope formula is y2 minus y1 over x2 minus x1. We've gotten used to using that formula, so it should be pretty simple to add into our problems. Now, when do we use point-slope form to write an equation? Like I said, it comes straight out of the name. We're going to use point-slope form of an equation when we're given a point and a slope, and we're asked to write an equation of the line. Or we can use this when we're just given two coordinate points, because all we need is two coordinate points to find a slope, like we've practiced before. So the steps are as follows. To write an equation when given a point and a slope, or two coordinate points, you're going to start off by writing or typing the point-slope equation. Y minus y1 equal to m times x minus x1. You'll type that in. Then you're going to identify a point. You can label them x1, y1. That way you know exactly where they're going in that equation you've typed down. Step 2 is to calculate the slope. Sometimes the slope will be given to you. Sometimes you'll have to calculate it. You might need to use rise over run or that slope formula, y2 minus y1 over x2 minus x1. And then, just like the other equations we've been using, we're going to substitute the slope and the coordinate point into the formula. Now, this last part is pretty important. I didn't make you fix the double negatives on your slope formula, but for the slope-intercept form, you are going to need to fix the double negatives. So what I mean by that is if you fill in this equation and you have, let's say, x minus negative 3, I want you to fix it. Minus a negative is really just plus. So we're going to simplify that down to one symbol and change any double negatives, minus a negative, to a positive. Subtracting negative numbers is just like adding. Okay, let's pop to the inside of these notes. These are a little bit lengthy today. We have a lot of writing to do because we're manipulating some formulas. The very first one is going to ask you to write an equation in point-slope form, given the following. So let's remember, and it has it written here for you, this is point-slope form. That's what we're trying to write. So really, we just need to fill in the slope and the x1 and the y1 from the point and the slope that are given to us. Okay, we can see exactly where these things belong. You're going to put the slope on the m, replace the m with slope. You're going to put the 3 here on the x1, that's what we've labeled it, and you're going to put that negative 1 here on the y1. Okay, let's do that. So we said y1 was negative 1. We said the slope was negative 2. We said the x1 was 3. Now, to get this to its final state, I do want to fix the double negatives, which means at the beginning, instead of y minus minus 1, or y minus negative 1, I'm going to just say y plus 1. Everything else gets to stay exactly the same, and I don't have to simplify anything else. That is the point-slope version of the line that passes through 3, negative 1 and has a slope of negative 2. Great. Your turn. Try number 2. I'm going to pause the video, and I want you to try number 2. All right, let's see how you did. Hopefully you noticed that you were given already the m, so you know exactly where you're going to put that in the formula. You're going to substitute it in. Then you have an x1 and a y1 given to you from the point. We're going to put those exactly where they belong. Once we substitute everything in, we see that we have minus a negative in the x part, so I'm going to just change that to plus to simplify it down. Y minus 2 equal to negative 3/4 x plus 7 is the point slope form of a line that passes through negative 7, 2 and has a slope of negative 3/4. Great. Now, number 3 and 4, I didn't automatically tell you what the slope is, but we've practiced doing slopes and finding slopes for a couple of lessons now. We have a whole formula for that. We have the formula slope is equal to the y2 minus the y1 over the x2 minus the x1. And that's exactly what we're going to fill out. Okay? The second y given to us is 5. The first y given to us is 6. The second x given to us is negative 2, and the first x is negative 4. I can throw that into my brain or into a calculator, and I would calculate that the slope is negative 1 over 2. Great. Now I have a slope, I have an x1, and I have a y1. That's all that I need to fill out the slope-intercept form formula. Starting off with step 0, I am going to write the equation down because it's easier to substitute things in when we know exactly where they're going. So y minus y1 equal to m times x minus x1. I am just replacing the y1, the m, and the x1. Let's do that. Y minus y1, we said y1 was 6, equal to negative 1/2, because that's slope, x minus x1. Then we just simplify it down, making sure we simplify those double negatives into a positive. And voila. There's your slope-intercept form of the line, where you've substituted in your slope, your x1, and your y1. Cool, you guys are going to try number 4. Now I'm sure you're looking at number 4 and you're saying, Miss Quigley, there are no coordinate points there. And I'm going to say, yes, there are. Remember, function notation is normally written as f of x equal to y. So we do have an x and a y coordinate. Let's label them. We have x1 and y1. Those are the first inputs and outputs that I have. Then I have x2 and y2. I'm going to pause the video, let you try this one. Remember, we're looking for that slope, and then we're plugging in all of the coordinate points that we need to the slope-intercept form equation. So here we go. We have found our slope by calculating the difference in the y's, y2 minus y1 over x2 minus x1. We throw that into our brain or to our calculator, and it would evaluate that the slope is 3 over 2, or 1.5. Then all we have to do is plug those numbers in for the slope, the x1, and the y1 that I have from the beginning. Again, we have slope, we have x1, we have y1. We've even labeled it this time. Plug them all in and change any of the double negatives to a positive, because subtracting a negative is just like adding. All right, at this point, the questions are going to change up a little bit. If we read this next question, it says, what is the equation in slope-intercept form of the line that passes through those 2 points? Well, we've used slope-intercept form before. That's y equals mx plus b. But we're only given 2 points. So we're going to continue to manipulate these equations around so that we have our equation written in slope-intercept form. This is actually really, really cool. So here's how this works. When we're given 2 coordinate points, okay, 2 points means I can find a slope. I'm going to label them just so I know where things are going. x1, y1, x2, y2. I can find my slope by calculating my slope formula, y2 minus y1 over x2 minus x1. Throw that into my brain or into a calculator. I'm going to evaluate that the slope is negative 1/2. Okay, now I have a slope and I have some points. We have now an equation we've learned about that is literally called point-slope form. So I'm going to take that point-slope form equation that we just learned about, considering I have a point and a slope, and I'm going to substitute things in exactly where they belong. So this is going to be y minus y1. Well, y1 is 6. Okay. M is negative 1/2. We just found that out. And then our x1 is a negative 4. Okay, I make sure I simplify that down so that it is in the final point slope form. Okay, there's my final point slope form. But this equation is asking for slope-intercept form. 2 extra steps to get it there. The first extra step is to distribute. Okay, you see that number in front of parentheses, you think back to when we solved equations, you say, oh, okay, I can distribute this. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times 4 is negative 2. If you don't trust me, check a calculator. Every other part of my equations just get to be brought down. And the very last step is to take the minus 6 that's on the same side as y, because remember, I'm trying to get y by itself, and I'm going to move it to the opposite side. But when I cross the line, I have to change the sign. This time, when we're doing this process, there are like terms. There's some straight up numbers called constants over there. When we have constants, we can go ahead and combine them together. I would have left over y by itself, the negative 1/2 x, didn't touch that, and then combining negative 2 and positive 6. That's positive 4. Now we think that this is right, but we can check our work on Desmos to ensure that we have these questions right. So let's watch how to solve these or check these equations in Desmos. Okay, so if we type in the equation that we ended up with, our slope-intercept form equation, negative 1/2 x plus 4. That's what the line looks like, but we're trying to see if it intersects those 2 points. So I'm going to go ahead and type those points in. Here's the first one. Here's negative 2, 5. Those points are both on our line, so we've done it right. If it wasn't right, our line would have looked really funky and it wouldn't have crossed both of those coordinate points and we would have had to start over. But it looks like this is correct because it is an equation in slope-intercept form that passes through those 2 points. We just checked it. I feel like we need to see this process one more time before I let you try one. So we're going to do number 6 together, and then number 7 will be yours. Again, this says, what is the equation in slope-intercept form of the line that passes through those 2 points? Slope-intercept form is y equals mx plus b. So we have to do the full process here. We need a slope and a point. But with 2 points here, this guy and this guy, we can find our slope. This should start to feel like the back of your hand. We know how to do this. y2 minus y1 over x2 minus x1. We throw that into our brain or into a calculator, and we're going to get that the slope is 2. Okay, so we can plug that into our point slope form because now we have a slope. Oops, that's not a highlighter. A slope, and we have a point. Sweet, so let's do that. We have y minus y1, so that's 2, equal to m times x minus x1, that's 3. I don't have anything to simplify here because there's no double negatives, but I don't want it in point slope form. I want slope-intercept form. So very easily, 2 steps. 1, distribute. 2, move, constant. And CLT, combine like terms. Those are the 2 things we have to do. Distribute, boom, boom. This is going to be 2x minus 6, because I'm multiplying 2 times x and 2 times negative 3. I have y minus 2 still on the other side, but when I move that 2, that negative 2, bloop, to the other side so it can combine with the negative 6, it's going to change signs. Cross the line, change the sign. So I'd be left with y equal to 2x, and whatever negative 6 plus 2 is, which is plus 4. Again, we can check our work here by looking visually at a graph. Does this slope-intercept form equation actually pass through the 2 coordinate points? Type them in and see. Pause your video right now. I actually want you to go check. Does this equation, when you type it into Desmos, and these coordinate points, when you type them into Desmos, show up? Do these coordinate points show up on this line? Go check. All right, hopefully you went and checked. Let's try number 7. So this one is for you guys. Remember, when you're given just 2 coordinate points, start by finding the slope, then plug your equation into point-slope form, and then rearrange using those 2 steps into slope-intercept form. Distribute, and then move the constant. Okay, pause the video and give it a shot. Here's my work, so let's see how you did. Remember, when we have function notation, it's really like coordinates because it's still inputs and outputs, or x's and y's. So just like before, we can still find our slope. y2 minus y1 over x2 minus x1. We have a slope of 3/2. That means we're putting that slope where the m belongs. We're also putting the x1 where the x1 belongs, and the y1 where the y1 belongs. Great, I substituted that, and then I got my green equation right here. But since I have a double negative showing up, I'm going to go ahead and reduce that down to just one single sign. Subtracting a negative is just like adding. Here's a really good point-slope version of this line, but it's asking for slope-intercept form. So I do the 2 steps. I distribute 3/2 times x is 3/2 x. 3/2 times negative 4, which I know you panicked about, but don't panic. Multiplying by fractions is easy. You have a brain and a calculator that can do it. 3 over 2 times negative 4 is equal to negative 6. Last step was to move that positive 2 bloop to the other side. Cross a line, change the sign, and we can combine our like terms. So my slope-intercept form equation is y equals 3 over 2x minus 8. The slope of 3/2 and a y-intercept of negative 8. So this process works because when we're given tables like the problem in number 8 that don't show me the y-intercept, when we did this before, we just looked for the y-intercept and included that as my b value. But this one doesn't show us the y-intercept, so now we can use this process to write both the point-slope form of an equation and the slope-intercept form. So the Maroon Maniacs are ordering customized foam hands to promote school spirit. School spirit! The table shows the cost of ordering different numbers of foam hands. Okay, write a linear model in point-slope form and slope-intercept form that represents the cost as a function of the number of foam hands. Great. We're going to write an equation, but we're going to write it in point-slope form and slope-intercept form. First thing I know is that from a table, I can find slope. Since both of these say slope in them, I know I'm going to need the slope. Okay? So here we go. This is x1 and x2. This one is y1 and y2. Great. Now I know exactly where these things belong in my slope formula. We have y2 minus y1 over x2 minus x1. Throw that into your brain or into your calculator, you're going to get that the slope is 4. So I can fill in point-slope form. Point-slope form is the one we learned about today. It's the y minus y1 equal to m times x minus x1 equation, where all I have to fill in is the slope, the x1, and the y1. But I have all of those coordinates already labeled. So I fill them all in. Y minus y1 equal to m times x minus x1. All things I've labeled on my screen already. Slope, x1, y1. Great. That is the slope-intercept form. I'm sorry, point-slope form. They did ask for that. Boom, done. But we also need the slope-intercept form, which means I'm going to do those 2 extra steps of distributing to have 4x minus 16 on the right-hand side, and then moving that 34 to the other side. Cross the line, change the sign. I can add the straight up numbers together and get y equal to 4x plus 18. And again, I could check and make sure that when I graphed this equation and this equation, that all of these coordinates, if I typed them in as a coordinate pair, show up on the two lines that I've written, because these are equivalent expressions. So the gist of today's lesson was that now that we know another formula called point-slope form, there's a lot more that we can do with these equations in manipulating them. Yes, it is a lot of manipulating things around and writing, but this is really cool because starting with just a little bit of information, starting with just 2 points, I can write a whole equation. I don't have to look at a graph and find the y-intercept. I can just use any of the information that it's already given me. We're going to be working with point-slope form in class, so come ready to learn a little bit more about this awesome form of an equation.